All right, now we're going to take a look at Aleks 3.4, number 7. It says, suppose that the number of bacteria in a certain population increases according to a continuous exponential growth model. What that means, continuous exponential growth model, is this formula right here, continuous compound interest right there. It's that formula, which sometimes with population, a lot of people will give you this, but these formulas are simply the same. I just always use this row to stay consistent, make things easier. So we're going to use this formula. That's because of this phrase right here, continuous. Once it says continuous, that means use the PERT formula. Okay, a sample of 1,000 bacteria are selected from this population. So the starting population is 1,000. So that's the P. And population reaches the size of 11,012 or 1,112. That's our A. We want to go until we get 1112. Whoops, forgot a 1. 3 ones. There we go. In 3 hours. So I don't know the rate, but I do know it's times 3 hours. Find the hourly growth rate parameter. So that means we're solving for R here. Again, I'll show you the algebra in a second, but I'm assuming most people would prefer the calculator. So I'm going to go over to Desmos and change our values for this particular problem. This is 1112. So 1,112 on the left, 1,000 on the right. This became an E to the power of, that's an R, and this is a 3. Now we don't know R, so we'd have to solve for it, and Desmos won't do anything with an R, so I'm going to change it to an X. Go to my home screen. The rate is going to be way down in here. I have to zoom in. It's this vertical line. Now, right now it's not clickable, but it looks like the rate's going to be between 3 and 4%. It's not clickable. To make it clickable, you have to do y equals the left side of the equation, and then y equals the right side of the equation. Now, if you do this, I'm going to change these so they're not all both red here. All right, now I'm going to go to the y value. Since this is just a number, they're going to cross the y-axis at that height. I know the x-axis crosses here, so I'm going to do is change my y-axis to be a number bigger than that so I can see it. So I'm just going to put it in 2,000. That way I can see the intersection. So here's the intersection. When I click it there, that's the exact rate. So the R is 0.03539. Now it says write your answer as a percentage. Do not round any intermediate compensations. Round your answer to the nearest hundredth. So when you go to a percentage, you move the decimal over twice. So R would be 3.54% when I go to the nearest hundredth. Nearest hundredth means 2 decimal places. 100 has 2 zeros, so this means 2 decimal places. So that's why I went 2 decimal places. And you have to shift to make a percentage. You shift your decimal over twice. So first I did that to get 3 point, and then out of the 539, that rounds to be 5.4. So this would be my solution right there. Now, if you're going to do this by algebra, you would try to solve, you have to isolate your variables. So I'm going to divide both sides by 1,000. The reason I'm dividing is because the 1,000 was multiplying times the E. So when I do that, that goes away. So I have 1, this, I'm not sure what this would simplify to be. I know it would at least simplify to be that, and it still keeps simplifying. Let me just put it over here and see if that's what it says. Well, it doesn't give me a smaller fraction. I'm trying to reduce this here to get a smaller number. 278 over 250. Can I just reduce those again? Yes, I could. Sorry, I'm just reducing these scene. Okay, I'm going to leave it as this. 139 over 125. So I'm trying to reduce this problem just to make it easier over here. So we'll say that is 139 over 125. that would equal e to the 3r. And the way to solve an exponential is you convert it to a logarithm. So we're going to convert to a log. And so I'd have log, your base stays the same, but then these two switch. So it'd be 139 over 125. All that would equal 3r. So the last step to get r by itself is you divide this thing by 3. And if you didn't know, a log with the base of e is the same thing as ln, a natural log. So what I'd actually type into the calculator is natural log of 139 over 125. When you write natural log, you don't have to put the base in. Natural log means the base is e. That is a log with the base of e. So I would type this into the calculator, and I should get the same answer, just not as a percentage. So let's see, ln for natural log of 139 divided by 125. All this divided by 3 gives me this number, which, yes, when you move your decimal over, it'll be 3.538 or 5, you know, they round it to get the same answer. That rounds to 3.54. This would round that 8, all that would round up to make that a 5.4 right there. So we did do it correctly.